Hello everyone, welcome to our channel Code with Sunny, and today I am going to discuss the problem longest increasing path in a matrix. Index number is 329 and the problem is of hard type of LeetCode. Okay, so before discussing the problem, let me declare that this problem is going to be like one of the best problem of the LeetCode, as it involves the concept of Dijkstra algorithm and also the slight dynamic programming concept that can be used here. Okay, and this problem can also be solved using the depth first search technique, like we are going to do as like in the graphs. Okay, so let's discuss the problem now and find out the best solution related to this problem. Okay, so we have been given an m into n integers matrix, that is the cell value is going to be integers and the matrix size is going to be m into n, and we have to return the length of the longest increasing path in a matrix. Note that the increasing path means the values that are going to be included in the path should be like in increasing order. Okay, and from each cell we can either move into the four directions, left, right, up or down, but we are not allowed to move diagonally or move outside the boundary of the cell. Okay, and we need to find the longest increasing path in a matrix. That is, in this example you can see 1 2 6 9 is the longest increasing path of length 4, where the path values are like 1 2 6 9, which are in increasing order, as you can find that. Okay, so let's look over the constraints, because sometimes constraints are going to be very much useful in figuring it out the best solution and the efficient one regarding the problem. Okay, so m and n is going to be like up to 200 and the matrix values is going up to 2 power 31 minus 1, and it should be like around 10 power 9. Okay, so let's discuss the problem with the help of example now. Okay, so as you can see here, I have taken a 2 into 2 matrix. Let's name index, put out the index 0 1 and 0 1 over here. And okay, so the best you can see the longest increasing path would be like going from 6 8 to 9 and going from 6 7 to 9. Okay, so this is the longest increasing path, but how we are going to find it out, this longest increasing path efficiently? Okay, so I'm going to talk about the very first technique, you can say the depth first search technique. Okay, so DFS you can call it as. Okay, so the using this technique, what I'm going to do is just to iterate for n into m cells and consider every cell as the source node. That is, you can consider this as a source node and start exploring all its neighbors. That is, its neighbor would be like 6. Can we move from 8 to 6? No. Can we move from 8 to 9? Yes. And if there are further more cells to the neighbors of the 9 that we can move, then start exploring that also and find out the longest increasing path. And this that solution can be like much, can take much time, like because we are going to consider every cell as the source node and find out the longest increasing path with the help of DFS. Okay, so beside that method, let's talk about some more interesting methods that I am going to use over here. Okay, so what are that interesting methods? Let's talk about. Okay, so I'm going to talk about my second method, which is nothing but method of priority queue, or you can say the method of minimum heap, or the concept of DJA, Dijkstra algorithm. Okay, plus slight use of like dynamic programming, you can also say, where okay, so starting with the base case, that is how we are going to think upon this problem and what should be the like idea to develop such type of situation to handle these cases with the help of such approach, like using the concept like Dijkstra algorithm and dynamic programming. Okay, so start thinking from the base case, like when you are at a particular cell like this cell, what should be the minimum answer including this cell? The minimum answer should always be 1. And what should be the minimum answer when you are only at this cell, considering this cell as a source node? The answer is obvious as 1, and this cell as 1, and similarly this cell as 1. So it gives us the idea that what minimum cell, that is, if you consider some cell as a source node, then the minimum answer is always 1. And okay, we need to find the longest increasing path, so we must start exploring the cells with the minimum value, that is 1, and start searching for its neighbors. Can this value 1 be increased such that it will contribute in the longest increasing path? Okay, so if you are not going to understand this, no need to worry about. I'm going to explain all these algorithms that I'm going to talk about with the help of example. Okay, So let's start with the if we are going to consider every cell as the source node, why not push all the cells into some priority queue like minimum heap and start picking the minimum one. Note that I am going to pick the minimum one because it is if you are going to find the longest increasing path, we need to maximize the minimum one and start making the minimum one to its maximum one. Okay, so I'm going to push this cell 1, the value is 1 and the cell's corresponding address is 0, 1, 0, and similarly for all the other cells the value is, if I'm going to start with this 6, the value is going to be 1 and the cell's address is 1, 0, and if you're going to start with this 7, the value is 1, minimum 1, and you can see the cell's address is 1, 0. Okay, so the previous one we have the cell's address like 1, 1. Okay, so here it will be 1, 1, and the all the 9 we have the also value 1 and the cell's address is 0, 0. Note that the value 1 is if you start from this cell with value 9, the minimum length of the path, you can say longest increasing path including this only as the source node, would be like 1, and the other one would be cells with value 8 would be like 1 and the cell's address would be 0 and 1. Okay, now we are going to maximize these values 1 and 1 and 1 and this one. That is considering all these as the source node, what should be the longest increasing path? Okay, so it should be like a concept similar to like longest increasing subsequence or something like this one. Okay, because we need to have the minimum one first and then start maximizing this minimum one and exploring all these possible situations. Okay, so that is the concept being involved here like dynamic programming. Okay, so I'm going to explain how this is going to happen. So okay, so if you start at this 1 and 0, 0, you can see I cannot I cannot move from any of the neighboring cells 9 to 8 and 9 to 7. So this cell is discarded and nothing is going to be pushed into the priority queue, minimum heap. Okay, so note that I'm going to maintain a minimum heap to find it out, because if you are going to maintain the minimum heap, each time we are able to pick up the minimum value of the longest increasing path that we have found till now and start maximizing it in all possible ways by exploring all its neighbors. Okay, so these all four coordinates are going to be pushed into the minimum heap with the value as the parameter as the first parameter. Okay, you can also use priority queue or the set as like concept in the involved in the dijkstra algorithm. Now you can see if I have discarded this one and I'm not going to push anything. Now let's explore the other cells, I'm going to explore this 0, 1. So you can see if I'm at this one, can I move to the neighboring cell like 8 to 6? No, we cannot move because 8 is going to be greater than 6. So can we move from 8 to 9? Yes, we can move. So this cell is discarded and another cell is going to be pushed with value 2 and the coordinates would be like 0 and 0. Okay, now how this value is going to be like 2? The value is going to be like 2 is like 1 plus the coordinate 1 plus 1 that I'm going to increment my current value. That is current value is 1, and if this cell is going to be included, my path length will always be incremented by 1. So that's why we have found this value as 2. Okay, so this cell is going to be discarded because I have already explored all its neighbors, and you can see let's talk about this cell. So 1, 0 and 7. Can we go from 7 to 6? No. 7 to 9? Yes, we can go from 7 to 9. So what should be the path length if we go from 7 to 9? New path length would be 2 and the corresponding end cell would be like 0, 0 again, and this cell is going to be discarded because it is already explored. And let's talk about this 1, 1. Can we go from 1 to 6 to 8? Yes. Can we go from 6 to 7? Already. Okay, so that is yes, we can go. So what should be path length? 2 comma 1 0 for going to 7, and again for going to 8 we can have like 2 0 1. Okay, so these are the four cells, you can say cells and their values and their coordinates that are again going to be pushed into the priority queue. And let's find it out what should be the maximum length of in longest increasing path. Okay, so if you are at this cell, then we cannot move to its next, and if you are at again this cell, we cannot move to its neighbors because 9 cannot be moved to 8 and 9 cannot be moved to 7. So if you are at 1 0, you can see I can go to 9. So if I can go to 9, my longest increasing path would be incremented by 1. So I will be at 3 and the corresponding cell coordinates would be like 3 and 0. Okay, 3 comma 0 comma 0. And if you are at 0 comma 1, you can see I can also go to the cell with value 9 that can contribute in the longest increasing path. So my path length would become 3 comma 0 comma 0. Okay, so you can easily see I can get 3 values. It signifies that we can move from 6 to 8 and to 9, and we can also move from 6 7 to 9. That is, we can have two longest increasing path whose length is going to be same, that is the length 3. So how we are going to get the answer? That is, take all maximum of all these values 1 and this 2 and this 3, which is which you can easily guess our answer can be 3 easily. Okay, so overall I am going to summarize what is going to happen here. So basically you are going to maintain a minimum heap and push all the values, that is minimum value can be 1 and the cell coordinates into this priority queue, and start picking the minimum value cell and its coordinate and try to explore all its neighbors. That is, if we can go to the neighboring cell following the rules of a longest increasing path, that is going to the neighboring cell would be like grid of my value of my current cell should be less than equal to the value of the neighboring cell. Then only this path can be increasing, and going to the neighboring cell is optimal or not. That is, going to the neighboring cell can increase the path length of longest increasing path or not. Then only we are going to the move to the next cell, next neighboring cell, and push that cell coordinates and the value, new value, into our priority queue. Okay, so this is what the entire method. If you're not going to still understand even a little thing, no need to worry about. If I'm going to explain with the help of the code also, then this thing will be much more clearer to you. Okay, so let's move further to understand the code. Okay, so here is the code. You can see I have defined a PIS pair int comma int because I am going to use it severally in my code, and bool is safe is going to denote whether my current cell is safe or not. And here I have int longest increasing path function. Minimum answer is always 1, and n is the grid size, which is number of rows, m is the number of columns. And you can see here I have a vector of a matrix of dp. You can call it as dp or any variable. Just for simplicity I am going to call it as dp, it doesn't matter. Now the minimum answer for each cell can be 1. You can see I have initialized it with 1, and I have a priority queue that is going to act like a minimum heap, where it would be like value comma cell coordinates, and it would be sorted according to this value, that is minimum value comes at the top of the priority queue. Note that I am going to push all the cells into the priority queue, that is the value 1 and the corresponding cell coordinates, and the reason is quite simple, that is the longest increasing path can start from any of the source cell. That is can be, that is the any of the cell can be the source of the longest increasing path. Okay, that's why I'm going to push all the cells and start processing its neighbors. Okay, so process while priority queue is non-empty, and pick up the coordinate of x coordinate of the cell at present at the top of the priority queue, and similarly y coordinate, that is the top of the priority will contain the minimum path length found till now, and we will start maximizing this minimum path length to its to find the longest increasing path. Okay, and check all the neighboring cells, that is x plus 1y, x minus 1y, xy plus 1, and xy minus 1. Okay, now if I'm going to check if my neighboring cell x plus 1 comma y is safe or not, that is within the matrix bound, and my it is going to follow the long increasing path rules, that is my current cell value is going to be like less than the neighboring cell value, and going to the neighboring cell is going to be optimal or not, that is it is going to, if it is going to contribute in the longest increasing path, my current value, that is dp of xy plus 1 is going to be strictly greater than this value, that is of neighboring cell value, then it is obvious and 100% sure that going to this direction will increase the longest increasing path in a matrix. Okay, so just change the neighboring cell value and push the neighboring cell value into the priority queue for further processing. It is like similar to the concept of dijkstra algorithm. Okay, and similarly check for x minus 1y, x comma y plus 1, x comma y minus 1, and finally what should be our answer? Like end cell, longest increasing path can end into the any of the cells. Okay, so if it is going to end in any of the cells, just we need to find the maximum of all the cell values. Okay, so just find the maximum, return the answer. and the time complexity would be like O of n into m into log of n into m, because n into m for each cell, and pushing the element into the priority queue would be like log of n into m. Space complexity would be obvious n into m. Okay, so let's submit this code and check it out if this is going to be an efficient solution or not. Yes, it is good. So if you have any doubts, let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.